Hi, this lesson is for section 9.3. This is Algebra 1, day 2, and we're starting with a warm-up. This first one is from chapter 7, and then these two are chapter 9. So what I would like you to do now is pause the video, maybe give yourself 5 minutes to do this warm-up. And I'm going to assume you pause the video and now you're coming back so you can quickly check your work. This is the solution to standard form, biggest exponent first, leading coefficient -6, degree is 5, and it is a trinomial. This one we need to jailbreak 18, jailbreak 20, and then you get this expression right there, and then when you combine like radicals, that is your final answer. And then this is a jailbreak. You need groups of 3 to escape. 1, 3 makes it out. A 4y squared are left inside. None of the y's escape. Okay, so that was review. Let's get to the next part of lesson 9.3, day 2. So these say solve. Yesterday we learned how to, or in the previous lesson, we did some similar to this. So let's just start and think when you are solving, your first step is to get the x all by itself on one side of the equal sign. In this case, you're getting the x squared all by itself on one side of the equal sign. So these are the same steps we've been doing since the first day of class in Algebra 1. Undo addition and subtraction by adding 1 to both sides. That leaves me a 0 here. And 16x squared equals 1. And then we want the x squared by itself. Undo multiplication by dividing both sides by 16. And we get x squared equals 1 over 16. Okay, and then yesterday we learned to get rid of the power of 2, or to undo x squared, we use a square root. And we also learned when we do this, we are going to get two answers, one positive and one negative. So we put the plus or minus in there. And then we have plus or minus the square root of 1 over 16. That can be simplified. Remember, if you have a fraction in a big, tall jail, we can, so I'm copying the plus or minus, we can give the 1 and the 16 both their private jails. Remember, if you start with a fraction, we want to keep the fraction going, so I'm still keeping the 1 in the numerator, the 16 in the denominator. I'm just giving them their own private jail. And now, if you have your perfect squares memorized, you know that the square root of 1 is 1, and the square root of 16 is 4. And remember, you can also have your calculator help you to decide if it's a perfect square. Let me get rid of this old stuff that's in here. If I do square root of 1, I get a 1. So if you get that whole number, then you know it's a perfect square. And remember that square root is right here. So I'm doing second x squared. And if I do second x squared, there's my square root symbol, 16, I get a 4. So that tells me it's a perfect square. Remember, if you get a decimal, then it's not a perfect square, and I would do my jailbreak. But this one is a perfect square. So this has two solutions, positive 1/4 and negative 1/4. Because remember, these are solutions to parabolas. So that means this parabola is opening up, and we have one solution over here at negative 1/4 and one at positive 1/4. Solutions to quadratics, I'm sorry. I think I said parabolas. Okay, now these next ones look very different than what we did in the previous lesson. I want you to notice the difference between these. It's that situation again where we have those parentheses. We saw this in chapter 8 with vertex form. Over here you have the x, and that power of 2 is sitting right on the x's shoulders. Over here, here's my x. The power of 2 is not sitting on the x's shoulders. It's outside these parentheses, and that's our power of 2. So it's similar to vertex form that we saw in Chapter 8. Now, your first thought should be, when I'm done, I want to get x all alone on one side of the equal sign, just like we did here. So we're always headed toward x all alone on one side of the equal sign. Right now, x is trapped inside these parentheses, and you can almost think of this 2 as a lock on these parentheses. So x is trapped inside here, and the 2 up here, the power of 2, is the lock. So the first thing you want to do is get rid of that lock. So to get rid of a power of 2, we're going to use that square root. Roots and powers undo each other. They're inverse functions. Whatever I do to one side, I have to do to the other. And remember, I need to add that plus or minus in over here because I'm going to get 2 solutions. Now what this does is it breaks this lock. So if I break that lock, the square root breaks that lock. So the square root and the power of 2 are both gone. What's left? X plus 2. So remember, the x was trapped inside the parentheses and the 2 was locking it. I got rid of the lock by using the square root, and what was left? X plus 2 equals plus or minus. Careful, I haven't done my jailbreak on the right there. I still have my square root over here. Over here, the square root and the power of 2 undo each other, but here I still have a square root. That's a pretty big number. I'm going to use my calculator to check and see if that's a perfect square, and really hope that it is. Yay, it is! So this is 14 times 14 is 196. So that means 14 is the square root of 196. So now I have x plus 2, still not x, equals plus or minus 14. Okay, this is very different. If you look over here, we just had x equals plus or minus, and this was a single number. Here, I have x plus 2 equals plus or minus 14. I still need to get that x alone. But what I want you to do at this step is think, we are going to get 2 answers, just like we did over here. But here, they were kind of the same number, the positive and negative of the same number. This time we're going to get 2 completely different answers. So I want you to say, okay, I'm going to split this now and say I'm going to write 2 equations and I'm going to get 2 answers. The first equation I'm going to write is x plus 2 equals, I'm going to say, positive 14. So what this expression means is x plus 2 equals either positive 14 or x plus 2 equals negative 14. So I want to write those 2 equations. X plus 2 equals positive 14, or I should say, and x plus 2 equals negative 14. Now I have 2 equations. I'm going to get 2 completely different x values. So let's solve this one. Minus 2 from both sides. And I get x equals 12. And then over here, minus 2 from both sides. This time I'm adding 2 negatives, so I get a bigger negative. I get negative 16. So these with the parentheses and the expression inside the parentheses, remember we call that a binomial. Notice your answers are 2 completely different values, positive 12 and negative 16. Over here, when we didn't have those parentheses, we just got plus or minus of the same number, plus or minus 1/4. Yesterday we got some answers that were like plus or minus 7, plus or minus 6. But when you have those parentheses, you're going to separate and get 2 separate answers. All right, let's try this one. Now this says the first step is to isolate this x minus 3 squared. So if you look at this equation, it's an equation, so I'm going to draw my line. I know I'm trying to get x alone. X minus 3 is trapped inside these parentheses, and there's that 2, that's the lock. I know to get rid of that power of 2, I'm going to use a square root, but I can't do that until I get rid of that 16. This x minus 3 squared needs to be all by itself on one side of the equal sign before I square root it. I'm going to show you this problem for a moment. When we started this, x plus 2 parenthesis, that whole package deal was all by itself on one side of the equal sign. This time, we have that 16 hanging out over here on this side of the equal sign. We need to get rid of that 16. This 16 is multiplied by this whole binomial. Remember, if we don't see anything in there, that's multiplication. So to undo multiplication, we're going to use division. And then here I have 16 divided by 16 is 1. So those 1 out. So I'm left with 1 x minus 3 squared equals, keep this in a fraction. Don't put that in your calculator yet. We'll see if we have any perfect squares when we get to the end. For now, just keep that fraction, 25 over 16. Now remember, multiplying by 1 doesn't do anything, so I don't really have to have that 1 there. So now, when this says isolate x minus 3 squared, that means get it all by itself on one side of the equal sign. You can see now on the front of the equal sign, all I have is that x minus 3 squared. Now I can blow up that lock by square rooting both sides. Put a big tall square root over here. So now what's left after I blow up that lock? Just x minus 3. What do I have over here? Square root. I still have my square root on that side of the equal sign of 25 over 16. Okay, I'm thinking I want to simplify this because I know when I have a fraction, I give them both their own jails. So this is the same as square root of 25 divided by square root of 16, and then over here I have x minus 3. If you put these in your calculator, or if you have your perfect squares memorized, you know the square root of 25 is 5, and the square root of 16 is 4. Oh, what did I forget? Oh, Mrs. Vara, shame on me. I forgot my plus or minus. Go back and add your plus or minus in here. I should have done it right up here. Whew, glad I caught that. You know how I figured it out? Because I knew I was going to get 2 answers. And if I don't have my plus or minus, I'm not going to get 2 answers. So there are my 2 answers. Now this is the step where I want to say I'm going to have 2 solutions here. One of them will be x minus 3 equals positive 5 over 4, and one of them will be x minus 3 equals negative 5 over 4. Okay, so let's solve here. We're going to solve these 2 equations. So this one I'm going to add 3 to both sides. I'm thinking for this one, if you want to put this in your calculator, you can do that. So this would be 5 ABC 4 plus 3. So 5/4 plus 3. And I get 4 1/4. So that is one answer. 4 1/4. Or we can turn that into a decimal. See this right here? Fraction decimal. If we do that. And that is the same as 4.25. Okay, that's fine. Either one of those answers are fine. Yeah, that's fine. Let me see. I think I'm going to do this again. 5 ABC4 plus 3, there's that 4 and 1/4. I think you can also turn that into an improper fraction. I think if I do second ABC button, it gives me 17 over 4. That's also another way to represent this. So let's put all those in there. All of those are acceptable answers. A mixed fraction, an improper fraction, or a decimal. Okay, let's try this side. Plus 3 to both sides. So these are the same, except for this is a positive and this is a negative. So this time I'm going to put negative 5 ABC4, and then, plus 3, and I get 1 1/3. I think I would like to turn that into a decimal. So I'm going to do second, see that little FD right there? That turns it into a decimal for you. I get 1.75. And then if I do this again, negative 5 ABC4 plus 3, this time I'm going to turn it into a improper fraction. So I'm going to do second and hit my ABC button again. Oh, something's wrong. Let's try that again. Negative 5 ABC4 plus 3. Okay. Second ABC, 7 over 4. So, or an improper fraction of 7 over 4. All right. One more. They're pretty much the same, except for our final answer is going to be a decimal. So we're going to definitely put our final answer in the calculator on this one. So let's clear our calculator. Okay, I don't see those parentheses in this one, so I'm just going to start by getting my x squared alone. 20 minus 4x squared. So the 20 is attached with addition or subtraction, so I want to use addition or subtraction to hop it over the equal sign. The 20 is positive, so I want to minus 20 from both sides. So 20 minus 20 is 0. Over here I'm left with negative 4x squared. Don't forget that subtraction is the negative. And 18 minus 20 is negative 2. Now I want to divide both sides by negative 4. So I get x squared equals negative 2 over 4. And that is the same as negative 1/2. If you simplify 2 over 4, you get 1/2. And that should not be a negative, because I should have divided both sides by a negative. So that should have been a positive. Sorry about that. So I'm just going to erase that. Now, square root both sides. And don't forget your plus and minus. I'm going to go up here now. So now I have x, because that square root blows up that power of 2. And I have x equals plus or minus square root of 1/2. So I'm thinking, well, I'm going to give them their own jail, because I know if they're in a fraction, I can do square root of 1 over square root of 2. Now I'm going to check square root of 1, although I think I already know square root of 1 is 1. Okay, so I have a 1 on the top. X equals plus or minus 1. And then I'm going to check square root of 2. Second square root of 2, but 2 is a prime number, so, oh yeah, I get a decimal. So I want to, so this is 1 over 1.4142, something like that. Now let's do 1 divided by that number. 1 divided by 1.4142. So I get 0.707. I want you to always give me 2 or 3 numbers past the decimal. I did 3 in this case. Okay? So same idea. Isolate the x squared, square root both sides, add your plus or minus. This one you just get a decimal answer. I think I'm going to save this for a separate video.